Hello students, my name is Avnish Jha. I'm a maths faculty and I'm going to teach you set theory from class 11th topic. And this is very important topic in your life because set once come in your mind, you have to be fascinated what is a set. Is your friend's name are the set? Your family member's name are the set? So in this type of question we can understand what can be the set or not, and this is said to be what set theory, where from where you can get the idea of set. So set is a collection of well defined and distinct objects. This is the very basic definition. Let us move ahead to discuss about the set and who discovered and from where it originated. You can see the father of sets named as George Cantor, who basically invented a new branch or give new dimension to our mathematics. That is what set. He founded actually the set theory, where he formulated so many things to define a set. Earlier, the set word was very confused and not defined well. So here we will define the set theory and the basic term set. What is that? A set is a well defined or well collection of things. You can see a well-defined collection of distinct objects. This is a very remarkable point. Distinct objects means they are very unique. Like if I talk about 5 first natural numbers. So what would you say? 1, 2, 3, 4 and 5. Yes, the counting numbers. And they are all distinct. They are not similar to each other. So the collection of this type of numbers is what? Nothing but the set. Yes. Now it determines which of the following. You can see like some examples I have put here, that all even numbers on the number line. Yes, obviously the set. All the good basketball players from the class 9th students. This can be the set or not. Good basket players. We don't have any parameters. So which are good, which are average and which are not good. So this is not the set. All even numbers on the number line. Yes, this is very definite thing. And the bad performers from the math batch of dancers. Again, we cannot say someone is bad, someone is good, someone is not so bad. Is that? Now next is what? All prime numbers from 1 to 100. Yes, this is called set. Next, numbers that are greater than 5 and less than 15. Yes, we have such numbers which are greater than 5 and less than 15. So this is called what? Set. Now we can easily identify from these all 5 examples which are set or not. Yes. Now next is some examples of symbols. These are very frequently used in set theory. Whenever you have to study this chapter, you will be familiar with these all symbols. So what are that? Let's see. First is what? Epsilon. This is epsilon naught. What does it mean? It means what? Belongs to. Belongs to. Means you belong to class 11th. So I can say like Sonu belongs to class 11. So this is what? Belongs to symbol. This is what? Not belongs to. This is what? Not belongs to. It means I can say that 0 doesn't belong to what? What? Natural number. You know, counting numbers are what? Yes, they are 1, 2, 3 and so on. So these are some very important symbol that will be frequently used in the set theory. That is what? And Z, Q, R, Z plus, Q plus and R plus. And these means very specific things like capital N set of natural numbers, capital Z set of all integers and Q rational numbers. You know, P by Q form numbers where Q not equals to 0 and R real numbers and then Z plus positive integers and Q plus all positive rational number. R plus, R is where R is real number, so R plus is all positive real numbers. If I use R minus, then negative set of all negative real numbers. So these are very frequently used terms and symbols wherever you have to apply in set theory. Not only in set theory, I must say, in everywhere in your maths. Yes, as well as science. So now let us move ahead. You can see some representation of sets. In what ways we represent the sets? We represent the sets in two ways. What are they? Roster form or tabular form, and set builder form or property form. Property form means where we define some properties and put some limitations. Yes, my dear students. So roster form or tabular form, you can see set A has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. And set B has no term and each one of them is known as element, like your family member. Suppose you have 5 members in your family. Each one of them is an element. Yes. So there is no element, null set or void set we can say. Set C, how many elements? 1, 2, 3, 4, 5, 6, 7, 8 elements are there. So set C has 8 elements and they are well defined and distinct and they are collection also. Next, set builder. We have to express in elements. There are no elements, just statement like A is such that A is defined like A belongs to natural number and stands for natural number. And what is the range of A? A is greater than A but less than 20. So what can I say in roster form? If I write this in roster form, A becomes what? Greater than 10 and less than. So 11, 12, 13, 14, 15, 16, 17, 18 and 19. And always put this braces to close the elements. And you can see this satisfies all the elements, satisfy the condition in the set builder. Set builder means we are going to build a set. Yes, we are going to build a set with statement and conditions. There is statement information about A. Nature of small a is capital N, which is natural number, and this is the range of A. Next we can say B. B belongs to natural number again and which is greater than 25 means I will start. There are infinite numbers possible, 25, 26 and I can put what? Triple dot, which shows infinite number of elements are possible. Now vowel, you know, A, E, I, O, U. So A, E, I, O, U. These are 5 vowels and this represents what? For set C. C is the collection of well defined and distinct objects. A, E, I, O, U, all are distinct, not the same, and each of them is treated as the element of this set. Is that clear? Hope I made this all clear, the types of sets. Now let us move ahead. What is that? Express the given sets in the roster form that I shown you just before. How will you show that? So how will you show A belongs to n by 2 and n is less than 10? So n is less than 10. How many natural numbers are less than 10? So 1, let me write. So natural number less than 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and all will have to be divided by 2. All will have to be divided by 2. Can you getting my point? Yes. Why? Because this is the value. You can also simplify, and now you can put what? Now you can take braces to close. This is opening and this is the closing, and this is what? Roster form for set A. Now next B. B, how will you represent? N is less than equals to 5, and what are they? And this is what? Square. You have to square it. So first you write 1, 2, 3 and 4. These are the numbers which are less than and also you have to take 5 also. So there are 5. So you will take the squares of each of them. So square of 1 is 1, 2 square is 4, 9, 16 and 25, and then again you will write in within the braces. This is the simplest way to convert a set builder form of set into roster form. So this is very easiest thing. I must tell you, you can now understand the everything. How will you express one form of the set into another form? So now next is convert the following sets given in roster into set builder. Set builder, just reverse. So I can say what? A is the set. A is the set. A is the set where A belongs to, or we can take X also, no problem. If you want to take variable X, I will take X. X says that X belongs to what? What? X is a vowel. X is a vowel. Okay, so X is the vowel. Okay, so we can write in this way. This is what? Set builder form. Now this is what? 2, 4, 6 even numbers. You can see even numbers, and B can be written as what? Suppose Y, such that Y, and Y is what? We have to define Y is an even number. Y is an even number. And which type of even number? Obviously they are positive, we generally consider. And what? And Y is less than equal to 10. We can consider this is the set builder form of this. So in this way we can define the types of set and how can we convert one form into another form. I hope I made all the things clear to you all, my students. So this is all about the types of sets and their interconversion from one form to another form. So let us move ahead for the next topic.